Hey guys, in this video we're going to be going over the singleton design pattern. So imagine that we had a class called school, and this school had a principal, a teacher, a person, and each student had a bunch of assignments, and we also have students inside of the school. Okay, so to do that we can just model it by creating a school class, and we won't extend anything, and it's just going to be a school class. School is going to have a principal, and it's going to have an array of teachers. Oops, I forgot the name. Principal, teachers, and then we're going to have private student, students. Okay, and let's just initialize the school with school name. So now, okay, yeah, I guess we can do that. Private string school name. And now we can say that school name is equal to school name. And okay, that's an easy way to initialize our school object. And we can just do this: school is equal to new school. Name of maybe like UCSD, and it'll work. The thing is, suppose we wanted the school to be kind of like a manager class. So by that I mean, suppose that we want it to be able to store all of this information, and we want to be able to access it from anywhere in our program. So far what we've been doing is we've been developing everything inside of our main static void main function. But suppose we had done something maybe a little more different. Suppose we had maybe like 10 more functions: public, static, other, function, and so maybe like when we reach to this part of our program, we would just call this other function because we wouldn't want our main function to become too large. And so we would go inside this other function class, and then maybe we would have another static method inside of another class over here, and we would go inside there, and then like static void other function 2. So after we've done all the stuff we need to do inside other function, we call other function 2. And suppose that we need to access this school object that we've created here. School is equal to new school. Suppose that we need to access this school variable or object inside of all of these other function variables, or methods I should say. Well, I mean, one way to do that is we can make it a static variable. We could simply say private static school. We can make it a static variable, and then we can initialize it over here. And then it becomes trivial because now all we need to do is we need to do school dot, maybe let me add some accessors so we can actually add some of the information. Source, and now generate getters and setters, and let's just make this one now. I'm going to get the school and set the school, easy stuff. And now we can just do school dot get school name. Okay, so why does this work? Well, it works because this school object, it's a static variable. This means that it resides in memory from the beginning of our main execution to the end of our main function's execution. When we initialize it to this new school, we're just changing the value inside memory at that point. We're providing this value of UCSD, and now the school variable is initialized and we can access it anywhere else in our program until the end of our main function. Now, what is the problem? What's the problem with doing this? Well, the main problem is we don't know where the school object is being initialized. Suppose that inside of this other function, inside of this function, we did this: school is equal to null. So now school is equal to null, and when we go inside of here, we're going to get a null pointer exception, which we can see because we've set it to null. If we have lots and lots of these functions, and at some point we set this equal to null, then we're going to have lots of little bugs because we don't know what's really happening to the school object. Where is it being modified? Is it being modified here? Is it being modified there? It's difficult to tell when you just have a static variable. And this is part of the problem. This is part of the problem with using static variables. You don't know where they're being initialized, or you might not know where they're being initialized. You might not know where they're being deinitialized, being set to null. And so this is a design problem. It leads to bugs that are difficult to weed out. So to avoid this, we can use the singleton design pattern. What we can do is, well, here we can see that we're only going to be using one school throughout the execution of our program. So this is where the name singleton comes from. Singleton. This is what the word actually looks like, singleton. Its name implies that we're only going to have one instance of school throughout our entire program. So let me show you what I mean. Public static school instance, and then what we're going to do is we're going to pass in a school name. Now, what we're also going to do is we're going to declare a static member. We're going to declare a static school member instance, and then we're going to see if instance is equal to null. And if it is, then we're just going to do instance is equal to new school name, and then we can instance. And actually, let's just get rid of this for now. And what we can do is we're just going to have a default constructor, so we won't actually pass in anything. This makes it a little easier to work with because now we can just create a new school. Okay, so now let's get rid of now we can get rid of that global static variable right there, and we can do this, school.getInstance. School is equal to school.getInstance. And we can call it anywhere. We can call it over here, for example, school.getInstance. Same school. So why is this advantageous? Well, it's advantageous because now we can't modify this static variable anywhere except inside of here. We don't have access to it anywhere inside of except our school class. We couldn't do this. School.getInstance is equal to null. Because, well, I mean, like, what exactly does this do? I mean, we're getting a compiler error because the left-hand side must be a variable. So we can't do that. We're not allowed to change anything except, we're not allowed to change this school static variable except inside of our school class, and that makes it easy to keep track of like this object's life cycle. And that's very advantageous. It also means that we can only have one school instance running throughout the existence of the entire program. Now, to further enforce this pattern, we can make our constructor private, and that makes it so no one can do this anymore. So now you can't do this. If you try to do this, you're going to get a compiler error because our constructor is private and it's not visible, forcing you to do this. And by forcing you, what happens? Well, now you can only create one school object throughout the entire life of your program. And in certain cases, this makes sense because, if our program only works with one school, then we would only want to initialize one school and we wouldn't want to change any of these values throughout execution of our program. Okay, so now that you've done this, once you get the instance, what can you do? Well, now we can set some values, right? Public void principal. So let me move this up here. If you're still kind of confused about how static variables work, this should make it a little more clear. Because this is a static variable that we can access using this syntax right here, school.getInstance. So we don't need to construct a school in order to call this method. We can just call it. We don't need a school instance or object or anything like that. We can just call it. And what that's going to do is it's going to initialize a static variable called minstance that is of type school. So this is a static variable, but this minstance variable, like the school, this is a school object, you can think about it. This is a school object, and we're just returning that object. Now, when we do something like this, set principal, and we do mPrincipal is equal to principal, what we're doing, let me write it down here. So we get school, and now we're doing mSchool.set principal. Oh, I spelled that incorrectly. Set principal. Do we have a principal up here anywhere? Yeah. Principal. Okay. So what we're doing now is we're first getting this instance. Is the instance null? Yes. The first time we ever call this method, the instance is null. So then we're just going to create a new school, and we're going to set that equal to. We're going to set minstance equal to that new school that we've just created. Then we return it. Now what we do is we do mSchool.setPrincipal. This is just an object, and we're setting some kind of value on it right here. We're setting the principal. Inside of this object, we're working with instance methods. This isn't static. It isn't static because this object right here, it isn't static. It's local. So we're doing set principal, and then we're doing mPrincipal is equal to principal. All right, I know that's a little confusing, but if you just look through this code more thoroughly in the docs, and you'll slowly start to piece it together. It's not intuitive the first few times you look at this, but the singleton pattern is very, very useful when you're working with large and complex programs. All right, so in closing, whenever you're working with static, generally you should only use it when you have maybe like, do we still have that class? I don't remember. Yes, we still have this. So when you're working with maybe like a global variable like this, in this case, this is a good time to use a static variable. Whenever you have a function that can be accessed by pretty much anywhere, it's also a good category or time to use static variables. Finally, whenever you need to store global state, whenever you need to store one variable across the entire life of your program, this is when you might want to use a singleton. If your program is large and complex and has many times you need to use only one or only like one instance of a type, then you should use the singleton design pattern. All right, I'll see you guys next time.